All right, guys, so we have worked really hard to get all of these rules, but the beauty of having all of them now is we can just work downhill when dealing with any situation as long as we apply the proper rule. So look, we want to do y equals 10 ln x and find its derivative. Well, that is just a constant times a function. And you know how to deal with a constant times a function. The constant goes through unaffected. You take the derivative of the part involving x. So here we have c times, c times f of x. The derivative is c times f prime. So the constant is 10. F prime is the derivative of ln x, but we just worked very hard to find the derivative of ln x to be 1 over x. So 10 times 1 over x, just 10 over x, problem solved. Think about how long it took to compute the derivative of ln x to be 1 over x, and look how nicely, once we have that in mind, we can just carve right through the problem. What about this next guy? Y is sine x minus 15x squared plus square root x minus 7e to the x plus ln x. It's a bunch of things being added together, but no sweat, because when things are being added together, we just take the derivative of each piece, keeping track of the plus or minus sign. So our y prime, we're going to have a minus sign between the first two terms, then a plus sign, then a minus sign, then a plus sign. What's the derivative of sine x? The derivative of sine x is cosine x. What's the derivative of 15x squared? Well, that's 15 times x squared, and the derivative of that is going to be 15 times the derivative of x squared. The derivative of x squared, bring the power down 2, reduce the power by 1, 2x to the 1. So that comes out to be 30x. What about x square rooted? Well, you know that square root x could be rewritten as x to the 1/2, and you know that when you take the derivative of x to the 1/2, well, like the derivative of anything of the form x to the n, you just bring the power down, that's going to be 1/2, and reduce the power by 1. Well, 1 less than 1/2 is minus 1/2. There we go. What about this 7e to the x? Well, you know 7e to the x is just a constant times the function e to the x, so the derivative of this is just going to be 7 times whatever the derivative of e to the x is, but the derivative of e to the x is just e to the x. So here we've got 7e to the x. And finally, plus ln x. What is the derivative of ln x? We worked really hard, but we found out the derivative of ln x is simply 1 over x. And with that in mind, we fill that in, and we've got our derivative. Anytime you have a function that is just a sum or a difference of a bunch of terms, you just take each of those terms' derivatives individually, inserting the plus or the minus sign accordingly from the original problem. This last guy, we've got a product. It's challenging formula whenever you take the derivative of a function which is a product, but so be it, it's doable nonetheless. So our first function, our f of x, is x. Our second function, our g of x, is ln x. When we take the derivative, what's going to result? Well, like it always does when you take the derivative of a product, it's going to be a carbon copy of the second times a derivative of the first, plus a carbon copy of the first times the derivative of the second. And when you run the numbers on this, g of x is ln x times the derivative of x. Well, what is the derivative of x? Think about this for a second. X is x to the 1. Take its derivative, bring the power down. That is 1x to the 0. And anything to the 0 power is 1, so this is 1 times 1, which is just 1. So ln x times 1, plus f of x. F of x is just a carbon copy of the first, that is x. G prime is the derivative of ln x. The derivative of ln x is 1 over x. So when you multiply this all out, ln x times 1 is ln x, and x times 1 over x, the x's will cancel and leave you with 1. So this guy has a derivative of ln x equals 1. Just a quick remark about this problem. When we took the derivative of x and ultimately got 1, one thing you could think of in your mind's eye, when you're taking the derivative of x, derivative is just slope. you know anything of the form mx plus b, the slope is just the number in front of x. So whenever you're taking the derivative of x, you could think of that as having a 1 in front, and the derivative of x would be the slope of the function 1x, which would just be 1. That's where that 1 came from if you want to think about it geometrically. But the long story short is using our derivative rules, applying our product rule, ultimately applying our rule about the derivative of ln x, we can get the derivative of this expression in not too much sweat, and it's just doable. And that's the important thing. That's what's interesting, is this function, crazy as it may be to even possibly try to imagine what that would look like, we actually have information about the slopes of the tangent lines everywhere.